Now, those summations, the summation of forces we have been talking about, is what we call, that summation is called resultant of the forces. But we are still talking of forces on a straight line. We're still talking about forces. Let's take, for instance, we have force 1 that is equal to 3 newtons. We have force 2 equal to 5 newtons. We have force 3 equal to 8 newtons. We have force 4 equal to, let's say, 4 newtons. Now, among all these forces, if we have the forces this way, F1, F3, F2, and we want to get the resultant. That means we have, the resultant will be 3. That's F1. Because it's in the same direction with F3. Will be plus 8. Because both of them are not in the same direction with F2, we'll have plus minus F2, which is plus, that is minus 5, because F2 is 5, minus 5, which gives 3 plus 8 minus 5, which is 6, which is 6 positive now, 6 newton, 6, which is 6 newton positive. Now, if we have to add, that is finding the resultant. The resultant now in this case is 6 newtons. Now, if we want to find the resultant of, let's say, F3 minus F3 minus F1 plus F4, the resultant will be, if we take the direction of F3 as positive, that means 8. If we take the direction of F3 as positive, that means 8, which is positive. Direction of F1, if we take the direction of F1 negative, that's F1, which is 3, minus 3. Then F4 plus 4, that will be equal to 8 minus 3, which is 5, plus 4, that is 9 newtons. That is the resultant. The resultant is 9 newtons. In this case, where we have something like this, we take the F1 direction as positive. That is, then we have, no, F3 as positive, sorry. F3 as positive. Then F1 again is against it. Then we have F4. You will see that F1, F3 and F4 are in the same direction. If we take that direction of positive, F3 and F4 are in the same direction. That is positive. We take it as positive. You can also take it as negative if you like. While F1 is in a different direction, opposite direction, which we now take as negative. Let's, for instance, let's take direction of F3 as negative. That would be minus 8. Because F4 is in the same direction as F3, so that means it will be negative. F1 is in opposite direction. So F1 becomes positive this time, plus 3. Then, because F4 is in the same direction as F3, which we have taken as negative, it will be minus 4, which will give us the resultant now in this case becomes minus 8 plus 3. That is minus 5, minus 4, that is minus 9. The same 9, but it's saying that the direction we took as positive this time was not the same direction we took as positive before. So that is why 9 is the resultant, but in the negative direction, because the forces we took that are even more this time were negative. That is why. So this is how we add forces in a straight line. Depending, let's say we have force F4, we have F3, we have F2, and we have F1. Look at them. It's like a kind of tug of war. When they are pushing, F4 and F3 are pushing F2 and F1 to get the resultant, that is the net force this time, to get the resultant of this arrangement of pushing between the two sides, pushing themselves. If we now decide which direction is positive, if we say the direction of F4 is positive, that means to get the resultant now, we have 4, which is F4 positive. F3 is in the same direction, plus 8. That means the direction of F2 becomes negative, which is minus 5. The direction of F1 becomes also negative because in the same opposite direction, minus 3. So the resultant now becomes 4 plus 8, which is 12. 12 minus 5, that is 7. 7 minus 3, that is 4. That's 4 newtons. So immediately a direction is taken as positive. The other direction becomes negative. If you took the given direction as negative, then the other direction automatically becomes positive. But if they're in the same direction, then summation, absolute summation of the forces. But if they're not in the same direction, we come to net summation, which is the resultant, depending on the direction and the signs. Now, even take for instance the work children do. Let's say there's this. There's another one here. This is J1, J2, J3. They are pulling J4. They are pulling J4. Tug of war. J4. The J5 is helping J4. J5. Helping J4. Then J6 is also helping J5 and 4. Now, if the amount of pull, J1 is bringing 5 newtons. J2 is bringing 7 newtons. J3 of pull, J3 is bringing 4 newtons. J4 is bringing 2 newtons. J5 is bringing is bringing 6 newtons. J6 is bringing 8 newtons. The question is that which group will win this tug of war? Which group will win the tug of war? Let us see the group will win the tug of war. Let's take the direction of pull of J1 as positive. So that means J1 5 plus J2 7, because the positive sign, plus J3 4. They are against J4. J4 2 negative. Those are minus. J4, because this is the positive. The next group now will be the negative, because we have taken the group by the left, J1, J2, J3 as positive. Then the group by the right will now be negative. Minus J4. Then J5 6. J8, J6 8. Let's know who will win. We have 5 plus 7, that is 12, plus 4, that is 16, minus 4 plus 6, 10, plus 8, 18. 16 minus 18, that will give you minus 2 newtons. So it shows that the group led by J4 will win. That's the group that has negative. The group that has J4 will win the tug of war, because they have more pulling force than the other group. What made them win? 2 newtons was what made them win. 2 newtons was what made them win in this tug of war. In many places, this is exactly how forces behave in a straight line. Forces counter forces. Sir Isaac Newton said in his third law of motion, action and reaction are equal and opposite for there to be equilibrium. Immediately, action is more than reaction, or reaction is more than action, there won't be equilibrium. So in this case, let's take the action as those in the group of J1, J2, J3. Reaction J4, J5, J6. We saw that the reaction was more than the action, and that's why there's no equilibrium. And the reaction will defeat this contest. If the resultant was 0, that means there will be no winner. That the two groups will be in equilibrium. None will be able to defeat the other. So this issue was to deal with forces in a straight line. How do we sum forces in a straight line to get the resultant? The summation is what we call the resultant of the forces. This is done depending on the direction of the forces. Forces in the same direction work together against forces in the opposite direction in a straight line. That is the lecture for today. Next time, we're going to deal with forces that are not in a straight line, but in different directions. We're going to deal with them. Thank you for listening.